Today we're going to take a look at what happens with the alkali metals and water. So the alkali metals are column 1 on the periodic table, or group 1, and we're going to take a look at what lithium, sodium, and potassium do when you put them in water. Because lithium, sodium, and potassium are so reactive with water, they have to be stored very carefully. So this is lithium, sodium, potassium, and when I purchase them, they come stored in mineral oil, and that puts a coating on the outside of the metal so that that metal cannot react with any water molecules that might be in the air. This is a piece of lithium metal that I cut off the larger chunk. Not only are the alkali metals reactive with water, but they're also very, very malleable. In fact, they're so bendable or malleable that you can cut them with a knife. And what you'll find is that when you expose a new area of that chunk, it's very shiny. And that's the actual lithium metal. What you see that's that dark gray color around it is lithium oxide. That's lithium atoms that have bonded with the oxygen in the air. So that's lithium. I also want to show you sodium. This is a chunk of sodium metal. Sodium is also very malleable. In fact, sodium is a lot more malleable than lithium. And so again, if I cut into it, you can see the shiny area. That's the sodium metal. And this one oxidizes much faster, so even as we stand here, that shiny is going away as the sodium atoms react with the oxygen inside the air. And potassium, of my 3 samples, is the most reactive, and it's going to react with that air even much faster. This is also much more malleable even than sodium, but this has kind of a cool purple color on the inside. I'm going to start with lithium. So again, here's my chunk of lithium, and I'm going to put it down in this water. We'll take a look at what that does. Those lithium atoms are reacting with the hydrogen inside the water, and it's breaking the water apart. So that's creating hydrogen gas. And then the lithium atoms are bonding to the OH that's left in the liquid, in the water, making lithium hydroxide. Sodium has a lower ionization energy than lithium, and so that means that it's going to be easier to pull an electron out of the outermost shell of a sodium atom than it is for lithium. So because it requires less energy, we should expect this reaction to be a little more vigorous. You should be noticing that the characteristic is that they react with water, they both dance, they both create hydrogen gas, they both move around. The sodium is reacting more vigorously than the lithium did. And that's because sodium has a lower ionization energy, so it requires less energy to get this reaction going. It's a lot easier to pull an electron out of the outer shell of a sodium atom than it is for lithium. This is potassium. We're going to pop that in water and see what happens. Notice that was the most vigorous of the 3. And again, that's because potassium is lower on the periodic table, which means that it has less ionization energy required to remove an electron out of that outermost shell.